Hello students, today we are going to study methods of heat transfer. There are three methods of heat transfer: conduction, convection and radiation. The method of conduction for heat transfer is applicable mainly in solids, and the method of convection of heat transfer is applicable mainly in liquids, and the method of radiation do not need the medium. The radiation method is the fastest method of heat transfer which can take place even in vacuum. Okay. Today we are going to start the method of conduction. Okay. Before starting conduction, let's make some difference between conduction and convection. Okay. Let's understand. Conduction, convection and radiation. In the method of heat transfer by convection, there are two important things. Medium is essential. And second important thing, it is applicable in liquid, and liquid molecule leave their position permanently to heat transfer. In this case, okay, let's see how the heat transfer takes place by convection method. Let's assume this is a container in which some liquid is there. Now what we are doing, we are supplying the heat. Due to supply of heat, temperature of the liquid increases. What is the relation in density of liquid at theta degree centigrade and at 0 degree centigrade? This is gamma liquid and delta theta. When temperature increases, you must be knowing that density of liquid decreases. And what happens when density decreases? The lower liquid molecule move to upper side and upper liquid molecule will move to lower side. Then again lower liquid molecule will move to upper side and upper liquid molecule will leave the will move to the lower side. So in the method of heat transfer, liquid molecule, first thing, medium is essential, and liquid molecule leave their position permanently for heat transfer. Understood? Okay. So medium is essential and the molecules of liquid leave their position permanently for heat transfer. Now let's understand the meaning of, and this method is dominant in liquid. Now let's understand the meaning of conduction. This method of heat transfer is dominant in solid. It is dominant in solid. Second important thing, the molecule of solid do not leave their position permanently. Only heat is transmitted through the vibration of the solid molecules. Solid molecules do not leave their position permanently. Heat is transmitted transfer of heat is through vibrations. Here few terms are important. First is variable state. What is variable state? Let's take a case of a road to which heat is being supplied. Suppose we are supplying heat to this road. When heat is supplied to the road, some part of the heat is absorbed by the element and some part is transmitted to the next adjoining element and some part is transmitted to the atmosphere. Okay. So what happens? Regularly temperature of different junctions keep on increasing. Temperature at different junctions are different and they keep on changing. They keep on increasing regularly. Okay. As the heat is being supplied. Okay. So this is called variable state. If temperature is T1, T2, T3, T4, then again temperature will become T1 dash, T2 dash, T3 dash and T4 dash. So temperature at different junctions are different. Temperature at different junctions are different and they are changing regularly. Okay. This is called variable state. Now let's understand the meaning of a steady state. When the surrounding is insulated, here we are putting insulators. Here also we have put insulators. Now, whatever heat we are supplying, if heat is being supplied at a constant rate, we have kept here constant power source. Then what happens? Some part of the heat supplied is absorbed by the element and some part is transmitted to the next adjoining element. After some time a state comes. After some time a state comes when temperature at different junctions are different. Theta 1 is more than theta 2 is more than theta 3 is more than theta 4. Temperature at different junctions are different. But dear student, at a particular junction change of temperature has stopped. Okay, at a particular junction change of temperature has stopped. In the direction of heat flow, temperature in the direction of heat flow, temperature is decreasing. At different junctions, temperature are different, but at a particular junction, change of temperature has stopped. This state is called steady state. And in this state, rate of heat received by a particular element, rate of heat received by a particular element becomes exactly same as that of rate of heat transferred to the next adjoining element. Okay. This state is called steady state. This state is called steady state. Okay. And this is in our syllabus. We will solve problems of only steady state. Here, we will understand the meaning of isothermal surface. What is isothermal surface? As the name indicates, isothermal surface is a surface at which temperature remains constant. Okay. Heat always flows normal to the isothermal surface. Heat always flows normal to the isothermal surface. Okay. Suppose here is temperature T, here is temperature T minus delta T. This distance is delta X. So delta T upon delta X, this minus, this is called temperature gradient. What is its meaning? Loss in temperature per unit length in the direction of heat flow. Loss in temperature per unit length in the direction of heat flow is called temperature gradient. Okay. And remember, in the direction of heat flow, this is heat source. Heat always flows normal to the isothermal surface. Heat always flows normal to the isothermal surface. and in the direction of heat flow, temperature decreases. Okay, so everything is clear. Temperature gradient, loss in temperature per unit length in the direction of heat flow. Isothermal surface, the surface at which temperature remains constant. The direction of heat flow always remains normal to the isothermal surface. Okay, these are some important terms. Now we will learn about the experimental result of thermal conduction. This is experimental result of thermal conduction. Dear student, if this is our sample, solid sample, if this is the heat source, here is temperature theta, here is temperature theta minus delta theta, this distance is delta x. So delta q upon delta t, this is heat flow rate, which is called heat current. This is minus Ka delta theta upon delta x. This negative sign indicates that in the direction of heat flow, temperature decreases. This negative sign indicates that in the direction of heat flow, temperature decreases. Okay. And what is thermal resistance? Thermal resistance R equal to delta X upon K into A. This is thermal resistance. And this is heat current, delta Q upon delta T. This is heat current. And this is thermal resistance. For solving, and what is value of K? K is called coefficient of thermal conductivity. Its theoretical value. This is the theoretical value. Less, greater than equal to 0, less than equal to infinity. This is theoretical value. For ideal conductor, this is infinity. For ideal insulator, its value will be 0. Okay. Dear student, now let's see what happens when rods are connected in series. Case 1. When rods are connected in series, suppose here are two rods. This is one rod, this is another rod. Here is temperature theta 1, here is temperature theta 2, and theta is the junction temperature. Its length is L1, length is L2. Coefficient of thermal conductivity. Here is K1, here is K2, and cross section area is same. Let us, this is A, this is A. So, in case of series grouping, let us assume theta 1 is greater than theta 2. In case of series grouping, heat current remains constant. Okay. Value of heat current remains same. So we can write equation K1A theta 1 minus theta divided by L1 equal to K2A theta minus theta 2 upon L2. With the help of this equation, we can solve junction temperature. And if you want the K equivalent, you can write the equation. If A is same, this is L1 plus L2, L1 upon K1 plus L2 upon K2. If cross section area is same. If L1 equal to L2, then K equivalent is harmonic mean. This is 2K1 K2 upon K1 plus K2. This is value of K equivalent in case of series. Okay. Dear student, if you want to write the equation of thermal resistance, the thermal resistance of first rod is L1 upon K1A. The thermal resistance of second rod is L2 upon K2A. And what is theta 1 minus theta equal to heat current into thermal resistance. Theta minus theta 2 equal to heat current into thermal resistance. In that way, you can solve any question. Okay. Now, dear students, let's understand the when rods are connected in parallel. Okay. When rods are in parallel. In case of parallel rod, temperature difference remains same. Figure shows two rods connected in parallel. This length is L, here is temperature theta 1, here is temperature theta 2, here heat current H1, H2, coefficient of thermal conductivity K1, K2, cross section area A1, A2, and heat current here H, here H. So we can write the equation H equal to H1 plus H2. And what is H1? This is theta 1 minus theta 2 upon R1. What is H2? This is theta 1 minus theta 2 upon R2. Okay. And what is K equivalent in case of parallel grouping? This is K1A1 plus K2A2 upon A1 plus A2. Dear student, if A1 equal to A2, then K equivalent will be arithmetic mean. This will be K1 plus K2 upon 2. Okay. This is how we will be solving the problems. Okay. So dear student, this is the concept when rods are connected in series and parallel. Okay. In the next lecture, we will be understanding the problems when the rods are in series and parallel. Thank you.